Hello everyone, this is Mathematics and we are here with the last chapter, 9th chapter of Pure Mathematics 1, Integration. And this topic is quite new for IGCSE students, and you're gonna have to pay close attention to this session to understand what the integration really means. So, guys, to be clear, integration is the exact reverse process of differentiation. Okay, so what were we doing in differentiation? So if we had ax to the power of n, by differentiation, d over dx, it would have been an, this n comes here, x to the power of n minus 1. But integration is exactly the reverse thing, okay? You're just gonna do it back here. And you're gonna do integration. This is the symbol for integration, okay? This one, to dx with respect to x. So integration with respect to x, and then again you get this one. So integration is the exact reverse process of differentiation. And we're gonna focus on integration in this session, and you'll have very nice questions in the exam from integration. They are very nice and I really like them. So you can assume integration as the reverse process of differentiation that we talked about earlier, and the integration of, in general, the integration of k times x to the power of n with respect to x is going to be k over n plus 1 times x to the power of n plus 1 plus c. So this may seem a little bit complicated in the beginning, but let me just mention one thing here, that n is not equal to minus 1. Why? Because minus 1 plus 1 is going to be 0, and this is going to be undefined. So we're not gonna have our n equal to minus 1. And so, guys, you can just phrase it in this way. The integration of kx to the power of n is going to be add 1 to the power, divide by that power. Okay? Add 1 to the power, n plus 1, and divide by that power, k divided by n plus 1. Okay? So, and about the integrating constant, which is the c here, we're just going to look at it here in this section. Okay? So, what is the integrating or integration constant? First step, try to differentiate I, double I, and triple I. Okay, so f dash x here is going to be 2x, right? Double I, f dash x here is going to be x squared plus the differentiation of x squared plus 3, which is going to be 2x, right? And the differentiation of f dash x here is going to be 2x as well. So the differentiation of all these three is going to be 2x, right? So as for step 2, there is a common answer to all differentiations above. True. Now, if we integrate 2x, which original function do we know it is? So we said that the integration is going to be the exact reverse process of the differentiation, right? So if I integrate f dash x with respect to x, it is going to give me f of x, right? This is what I know about integration. But I have a question. If I integrate 2x, which one of these three is going to be my answer? Or any other function that has x squared, like x squared plus 4, x squared minus 100, doesn't matter. Any of these could be my answer, right? Any of these. So, since I don't know the constant term, okay, because the constant term gets eliminated here. Why? Because when I have 3 here, these 3 is going to be 3x to the power of 0. And when differentiating, 0 comes here, gets multiplied by, and this whole thing is going to become 0 when doing the differentiation, right? That's why the constant term becomes 0 in the differentiation and gets eliminated. But when we want to bring it back in integration, we don't know which constant it is. So we're just going to put a plus c instead of that constant term. And if you have extra information about the integration or about the original function or anything, if you have extra information, we can find out the value of that c. But if you're generally asked to find the integration of an expression without having any extra information, then you must mention that plus c in the end, okay? And as for the third step, now if we integrate 2x, which original function do we know it is? We don't know. So for there must be constant that we don't know the value of it. There must be a constant. Okay, a grammatical error. My bad. So, note, never forget plus c in the end of your indefinite integrals, of course. So, guys, from f of x to f dash x, if you want to differentiate f of x, if you want to get from f of x to f dash x, then you differentiate. If you want to get from f dash x to f of x, then you integrate, okay? And we have 2 questions here. Both are from chapter review 9. And we're gonna do them and end this session. Well, this all goes back to your practicing, okay? And we're gonna do a few questions here. But while doing the past papers, everything would be crystal clear for all of you, because the questions there, the exam style questions, are going to be not a lot more difficult, are going to be a bit more difficult than these questions, these topicals in the book, and we're gonna deal with them and get the hang of it together. So, given that f of x is equal to 9 over x squared minus 8 root x plus 4x minus 5, where x is greater than 0, find the integration of f of x with respect to x. Okay, sure. So guys, first things first, you are going to write your expression in the index form, okay? So I'm just gonna write 9x to the power of minus 2 minus 8x to the power of 1 over 2 minus 5. If you can't do this, just go back to the first chapter and do all of it again, because the first chapter is all about indices, okay? And we have to write this in the index form to be able to integrate it. So, the integration of f of x with respect to x is going to be add 1 to the power, divide by that power. So, x minus 2 plus 1, this is going to be 9 over minus 2 plus 1, right? Minus x to the power of 1 over 2 plus 1 over, okay, minus 8 over 1 over 2 plus 1. And in the end, x to the power of 0 plus 1 and 5 over 0 plus 1. And this is going to be my integrated function. So, the integration of f of x with respect to x, this is x, is going to be 9 over minus 1, which is going to be minus 9, okay? Minus 9, x to the power of minus 1. Minus, okay, 8 over 3 over 2, right? 1 over 2 plus 1 is going to be 3 over 2, and 8 divided by 3 over 2 is going to be 8 times 2 over 3, which is going to be 16 over 3. 16 over 3 times x to the power of 3 over 2. And then minus 5 over 1, which is going to be minus 5x here, plus c. Do not forget the plus c, guys. Okay, so if you want to check your answer to see if it is correct or not, then differentiate this one back to get this one, okay, to get this part. If you didn't get this one, then it means that you did something wrong. But if you got this one, congratulations, you did it right. And do not forget to mention the plus c here. Again, do not forget to mention the plus c here. It is very important. So let's just be more clear and to be more sure. Minus 1 is going to be minus 2. And minus 9 times minus 1 is going to be 9. So it's going to be 9x to the power of minus 2, which is going to be this one. So the first term is integrated correctly. Minus 16 over 3 times x to the power of 3 over 2. 3 over 2 times 16 over 3 is going to be 8. Okay, so minus 8. Minus 16 over 3 times 3 over 2 minus 16 over 3 times 3 over 2 is going to be what? Minus 8, which I have here. And when I subtract 1 from the power, it's going to be 1 over 2. Or if I want to write it in the normal form, it's going to be root x. So the second term is integrated. Is integrated correctly as well. Okay, this one, and in the end, minus 5x. Okay, the power of this one is 1. 1 times 5 is going, 1 times minus 5 is going to remain minus 5, and 1 minus 1 is going to be 0, so the x gets eliminated and the minus 5 remains, which is here. So my integrated function was all good. And question 14. Given that f dash x is equal to 2 minus x squared to the power of 3 over x squared, where x is not equal to 0, show that f dash x is going to be 8x to the power of minus 2 minus 12 plus ax squared plus bx to the power of 4, where a and b are constants to be found. Okay, sure. So I'm just going to expand it, right? So let me do the expansion. 2 minus x squared to the power of 3. So I did the expansion in the previous session, but seriously, we know that a plus b to the power of 3 is going to be a to the power of 3 plus 3a squared b plus 3ab squared plus b cube. Okay, a cube. Did I say a cube here or a squared? If I say a squared, my bad. It is a cube. So I'm just gonna do 2 to the power of 3, which is going to be 8. Okay, plus 3 times a squared, 2 to the power of 2, times minus x squared. Okay, plus 3 times 2 times minus x squared to the power of 2, plus, okay, no, okay, plus b cube, which is going to be minus x squared cube. And by writing this one, okay, I'm going to have 8 minus 3 times 4 is going to be 12x squared. Okay, plus, this is going to be plus 3 times 2 is equal to 6. 6 times 1 is 6x squared. And this is going to be minus again, x to the power of 6 all over x squared, right? This is my f dash x. So this is going to be 8. I can write this one as this, as we had in the first chapter. I can just separate the numerator. 8 over x squared minus 12x squared over x squared plus 6x, this is x to the power of 4, my bad. 6x to the power of 4 over x squared minus x to the power of 6 over x squared, which is going to be 8x to the power of minus 2 minus 12 plus 6x squared minus x to the power of 4. And this is our answer. And where a and b are constants to be found, you can also mention that a is equal to 6 and b is equal to minus 1. And that's the complete answer to part A. And for part B, given that the point minus 2 and 9 lies on the curve with equation y is equal to f of x, find f of x. Okay, so we know that f of x is equal to the integration of f dash x with respect to x. So it is going to be the integration of 8x, 8x to the power of minus 2 minus 12 plus 6x squared minus x to the power of 4 dx. Am I right? So this is going to be add 1 to the power, divide by that power. This is going to be minus 8x to the power of minus 1 minus 12x plus 2x cubed minus 1 over 5x to the power of 5 plus c. Okay, and I know that this passes through the point. What was the point? Minus 2 and 9. Minus 2 and 9. This is the extra information, guys. With this extra information, we can find the value of the integrating constant, okay? I can just say that 9 is equal to, or let's say f of minus 2 is going to be minus 8 times minus 2 to the power of minus 1. Minus 12. Okay. Minus 2 plus 2 times minus 2 to the power of 3 minus 1 over 5 times minus 2 to the power of 5 plus c equal to 9. Okay, so I'm just gonna write c equal to 9 plus 8 times minus 2 to the power of minus 1 plus, this goes to the right hand side, 12 minus 2 plus, this one's minus 2 to the power of 3 plus 1 over 5 minus 2 to the power of 5, which is going to be, okay, 9 plus 8 over minus 2 is going to be minus 4, okay, minus 24, okay, and this is going to be minus 8 times 2 is going to be minus 16 times minus 1 is going to be 16. This is going to be plus 16 plus, minus 32 over 5. And our c is going to be minus 47 over 5. And in the end, my f of x is going to be minus 8 x to the power of minus 1 minus 12x plus 2x cubed minus 1 over 5 x to the power of 5 minus 47 over 5. And this is my answer to this part. So just to check my answer, I put minus 2 instead of x here again, and I should get a 9, right? So let's say minus 8 times minus 2 to the power of minus 1 minus 12 times minus 2 times minus 2. Again, it's going to be plus 2 times minus 2 to the power of 3. And this is going to be minus 1 over 5 minus 2 to the power of 5 minus 47 over 5. And our answer is 9, so the integration is all correct. Thank you, guys. We have finished Pure Mathematics 1 syllabus successfully, and we are going to start doing past papers. And I'm gonna start uploading FP1 videos as well. So till the next sessions, see you and take care.